hello grade 12s. Today we're going to talk about the remainder theorem. Now please note the remainder theorem, as with a polynomial division, is not actually that important and won't be examined in the examples as in the examples that we're going to discuss here. So if you do go through the examples and you're slightly worried you don't understand them, again, this is just background to the more important information that will come next. Okay, so if you had watched the video on polynomial division, you will know that if I take any polynomial, in this case x squared minus 2x plus 2, and I divide it by x plus 3, which now is called our divisor, then either by using the long division method I discussed, or by using the algebraic manipulation method, you will have a quotient, and then you will also find a remainder. Now, we can convert this format into the following format, and we can do this by simply multiplying every single term by x plus 3. So if I multiply that fraction by x plus 3, I get back to the polynomial, and then there's the quotient multiplied by the divisor, and then also if I multiply that by the divisor x plus 3, I end up with the remainder. Now yesterday we called this the Euclidean property. So the Euclidean property says any polynomial can be written as the divisor times the quotient plus the remainder. And we're going to talk about this just a little later, but again people, not all that important. Please don't worry too much if you don't understand this Euclidean property. Now, the remainder theorem deals with the following question. The remainder theorem asks, how do we determine the remainder without doing the polynomial division? So if they go and they give me the polynomial and they give me the divisor, how do I calculate the remainder without having to go first and do the polynomial division and calculate the quotient? Now, in order to do this, very simple and straightforward, the remainder theorem says if I take my polynomial, so in this case, x squared minus 2x plus 2. Now I'm going to set that equal to fx, and there's a good reason why I'm going to set that equal to fx, you will see just now. Then the next thing I need to do is I need to take the divisor. So what am I going to divide into that polynomial? In this case, x plus 3. So I take my divisor and I set my divisor x plus 3 equal to 0. And I quickly solve that, getting x is equal to negative 3. Now, the remainder theorem says if I want to get the remainder when I divide that x squared minus 2x plus 2 by the divisor of x plus 3, I can find the remainder simply by substituting that negative 3 into my polynomial. So I substitute negative 3 into the polynomial by saying it's negative 3 squared minus 2 times negative 3 plus 2. And then if I calculate that, I end up with 9 plus 6 plus 2, which, lo and behold, 17. That is my remainder. And I know for a fact that's the remainder because I already did the polynomial division on this problem yesterday, so I know 17 is my remainder. Now, just for those of you interested to know how this works, it's actually very simple. The moment you substitute negative 3 in here, you are also substituting negative 3 into this bracket, because remember the polynomial can always be written as the divisor times the quotient plus the remainder. So effectively, if you're substituting negative 3 into the polynomial, you're substituting negative 3 in there and in there. Now, the end result over here, if I substitute negative 3 in there, is I end up with 0. So obviously 0 multiplied by this bracket means all of that is 0, so all that remains is the remainder. And that's how the remainder theorem works. So it's a very easy, simple, straightforward way, bypassing your polynomial division, to calculate the remainder if your polynomial and your divisor is given. So let's do another example on this remainder theorem, and you'll see it's super easy to use. So next example is example 1 on page 176, and they ask, calculate the remainder if fx is divided by 2x plus 1. So if I just want to calculate the remainder, they don't ask at all for the quotient, just the remainder. I will then go and first take this little divisor, 2x plus 1, and I will set that equal to 0 and quickly solve that, getting 2x is equal to negative 1, and then getting x is equal to minus 1 over 2. Because that's what needs to be substituted into fx there to find the remainder. So my remainder is just going to be equal to the f of negative a half. And yes, I'm going to be super, super lazy here, and I'm just quickly going to use my calculator to work that out. So I'm going to now go and say that means that it's 2 times negative a half cubed minus 4 times negative a half, whoops, let's try that again, apologies, there we go, minus 4 times negative a half squared plus negative a half, and then lastly plus 2. And I end up with a quarter. Let's just double check that. 2 times negative a half cubed minus 4 times negative a half squared plus negative a half plus 2, and I end up with a remainder of a quarter. So that's telling me if I divide this particular polynomial, by that divisor, I end up with a remainder of a quarter. And you will also see, if you are following in the textbook on page 176, that is the correct answer. The remainder is a quarter. So very easy and simple and straightforward to use. Now, the remainder theorem can also be used in another way. So just for interest's sake, we're going to look at another way they can ask it. Good news, the next example, they used to have in the past examinations. So they did used to go and ask these type of questions, but in the last 8 years, they really haven't asked these questions. So again, you can do it for interest's sakes, but I doubt whether the following question is going to be in the examination. So in the next question, example 2 on page 177, they say, when fx which is equal to x cubed plus mx squared minus 5x plus 4, when that polynomial is divided by x plus 1, the remainder is 10. So now they tell you, this is the polynomial, this is the divisor, and that's the remainder. So they've given you the remainder, but they now ask you find the value of the variable m. So there, right there, is a little value, m, that I don't know what that is equal to. But luckily I know. According to my remainder theorem, the remainder is going to be equal to, in this case, the f of negative 1. And again, how did I get that negative 1? I got that negative 1 straight from the divisor. So if you quickly just want to somewhere go and write down the divisor equal to 0, then you'll find x plus 1 equal to 0, which means x is equal to negative 1. And that's how you know to sub in the negative 1 in there. So my remainder is equal to the f of negative 1. But they told me my remainder over here, they told me it's equal to 10. So I can then substitute the remainder with 10 because that's a given. And then I can substitute negative 1 into the polynomial over there. So every place where I have x, I substitute negative 1. So I get negative 1 cubed plus m times negative 1 squared minus 5 times negative 1 plus 4. And then I end up with 10 is equal to minus 1 plus m, because obviously when you square a negative it becomes positive, plus 5 plus 4. And then finally, m is going to be equal to minus 1 plus 5 plus 4. That's going to be equal to 8, and then 10 minus 8 is 2. So I end up with m having a value of 2 if this polynomial is divided by that divisor and the remainder is 10. The only way this could work is if my m value is equal to 2. So like I said, this used to be a very common question in the final exam, but for the last 8 to 10 years, they haven't asked these questions. So again, this is not really that important. It's just for interest's sake. Good. Now, after we've discussed the remainder theorem, we need to go to the next one, the factor theorem. And this is where things start getting important. So all of the stuff we've discussed up until now is very much just background information, but this is where it starts becoming important. So now you have to concentrate, because if you don't understand the factor theorem, you will not understand the next video, which is going to be on solving third-degree equations. Okay, now in order to understand the factor theorem, I just quickly need to refer to this, just so you can understand why the factor theorem works the way it works. If I look at the factors of a number 12, then I know the factors of the number 12 are 1, 2, 3, 4, 6, and 12. Because 12 divided by 2 is 6, 12 divided by 4 is 3, 12 divided by 12 is 1. So therefore, if I divide a number by its factor, the remainder is 0. So let's write that down. A number divided by its factor leaves a remainder of 0. And hopefully you will then understand how this connects to the remainder theorem. Because the remainder theorem said if I want to calculate the remainder, when I divide a divisor into a polynomial, I then just do a substitution. But the factor theorem says if I go and I divide a divisor into a polynomial and the remainder is 0, then that divisor has got to be a factor. So let's write that down. So we're going to write down and say a polynomial divided by a divisor giving a remainder of 0. Means that the divisor is in fact a factor. So this is the important bit that you need to realize. So, polynomial divided by a divisor giving a remainder of 0 means that that divisor, if it gives a remainder of 0, is a factor of the polynomial. So the way that translates into a mathematical sum is the following. It says, prove that x plus 2 is a factor of that particular polynomial expression. Now if I want to prove that this is a factor, first things first, I have to calculate the remainder if this polynomial is divided by that divisor. So we're going to go back to the remainder theorem and we're going to say, let's set fx equal to that x cubed plus 9x squared plus 26x plus 24. And then quickly, again, I'm just going to do it here on the side. I'm going to take that x plus 2, the divisor, set it equal to 0. And that's going to give me x is equal to negative 2, because this will tell me what needs to be substituted into fx to get the remainder. So we're going to say the remainder then is equal to the f of negative 2. And then if I put that negative 2 in here, so I substitute it into the x cubed, and then plus 9 negative 2 squared plus 26 times negative 2 plus 24. And again, just to speed things up, I'm going to use my calculator. So I'm going to say, put that negative 2 cubed plus 9 times negative 2 squared plus 26 times negative 2 plus 24. And if I sub that in, I end up with 0, which means that 0 is my remainder. And then logically speaking, if my remainder is 0, it means that x plus 2 is a factor. And that's the important deduction of this factor theorem, is that if I divide a divisor into a polynomial and the remainder is 0, then that divisor is more than just a divisor, it's actually a factor. So we're going to play a little bit more with this factor theorem, and then hopefully you'll see the importance of this one, especially for the next video. So here's an example, example 1 on page 178, and it asks you to factorize the following expression. Now up until now, you guys were unable to factorize these expressions. And that was simply because we never taught you how to factorize cubic polynomials that has all of these terms. I mean, the best you could have done so far was the sum or difference of cubes. Those ones we taught you to factorize in grade 10, but this expression you've never seen before. Now, the first thing we need to do before we can factorize this expression is we need to find a factor. And we're going to find that factor by simply using what we call inspection. And to use inspection, we're going to first go and say set fx equal to that expression, which is 2x cubed minus x squared minus 13x minus 6. There we go. Now, I'm now going to go and I'm going to sub a range of values in here. And that range of values, in order to help me to do it faster, I'm again going to use my calculator. So, subbing in, the best mode to use here is the table mode. So I go mode 7 for table, and I type that particular expression in there. So it's 2x cubed minus x squared minus 13x minus 6. So I've got that one. Now I'm going to leave gx blank. I'm just going to press enter again. I'm going to start at -2. You could have started way earlier. You could have gone from -5 to 5. I'm just going to check from -2 up until 2, and I'm going to step in once. Now, what I'm trying to spot, and that's what I get immediately over there, is that 0. Because the moment I get that 0 over here, I know that that -2 can give me a factor. But now you have to be careful, because now we have to work backwards. So we are now going to say the f of -2 gave me 0. Therefore, and this is the part you have to be careful with, x plus 2 is a factor of fx. So just remember, to get that value in the remainder theorem to sub it in, we had to go and set this equal to 0, which meant there was a sign change. So if I then get the value that gives me 0, I have to then go back and find that sign change to say that x plus 2 is then the factor of fx. So immediately, in order to factorize that, I can then go and I can make this deduction, 2x cubed minus x squared minus 13x minus 6. My first factor that I found is x plus 2. Right. Now, in order to find the rest of this, you need to understand something very important. If I am going to go and factorize a cubic polynomial, because of this degree of 3, I should actually have 1, 2, 3 of these binomial linear factors. That's generally what happens. Sometimes what happens is I have a linear factor over there, and then I have a quadratic factor over there, because obviously x to the power of 1 times x to the power of 2 gives me x to the power of 3. But then you have a problem because the quadratic factor can't factorize. But for now, we're just going to say, if we can find 1, 2, 3 linear factors, then yes, it's going to be 1, 2, 3 linear factors to get to that. Now, in order to understand this, I'm then going to first show you how to find that quadratic factor by means of inspection. So again, if you don't understand this, right after this, I'm going to do the long division. And then you can look at the long division. But this is again just an algebraic manipulation where what we do is we say, I know for a fact that in order to get this cubic polynomial, it's got to be a linear binomial times normally a quadratic trinomial. That's normally what happens. A linear binomial times a quadratic trinomial gives me this expression. Now, just like we did when we factorized trinomials, I say the first term here times the first term there has got to be the first term over here. So x times 2x squared is going to give me this 2x cubed. And the last term here multiplied by the last term over there is going to give me that last term, the -6. So 2 times -3 is equal to the -6. Now, over here is our little problem area. I know I've got to have an x over here. And because I know I've got to have an x over here, I recognize the fact that I do not know what the coefficient of that x is. So because I don't know what the coefficient of that x is, this is the inspection part. This is the part where I now have to go and figure out what is that little coefficient of x. Now, in order to do this, I'm going to do a multiplication over here, saying 2 times 2x squared gives me 4x squared. And I would love to do a little multiplication over there, but currently this value is missing. But what you do notice is even though this coefficient of x is missing, if I multiply x by x, I end up with an x squared. I just don't know what the coefficient is. Now, the reason I did these two multiples is very, very simple. This is the only product that will give me x squared, and this is the only other product that will give me x squared. None of the other products, because remember, if I multiply that, it gives me x cubed. If I multiply that, it gives me, well, actually, if I multiply those, it gives me x. I'm looking for the two products that gives me the x squared. And then what I do is I say to myself, how will these two added together give me this minus x squared in my expression? And if you work backwards, you say 4x squared minus 5x squared gives me the minus x squared in the expression. Now, the moment you have that minus 5x squared, you then go and say, okay, but I need to get that by means of this product. So x times minus 5x is then equal to that minus 5x squared. Now, this means that that factorized gives me x plus 2, and then the quadratic trinomial is 2x squared minus 5x minus 3. Now, a lot of people worry about that minus 13x, going, how are you sure that this times this is going to give me that minus 13x? And I can show you. If it works for the x squared, it automatically works for the x, and I can prove that to you. Over here, if I go and multiply these two terms, x by negative 3, I end up with negative 3x in order to get that one. But there's another product that gives me x, and you should spot it. It's over here. 2 times negative 5x gives me negative 10x. And what happens if I go negative 3x minus 10x? I get that minus 13x. So I know for a fact this is the correct factor. And then to finish it up, I can then just go and say I've got x plus 2, and then I'll factorize this trinomial saying it's 2x times x, and then that 3 is going to be specifically 3 times 1, because I need minus 6 and plus 1 to get this particular one. So finally, that polynomial expression factorized gives me this. But like I said, if you did not like this method that I used just now, you could have gone for the long division. So let's quickly do the long division. In the long division, I will say I've got 2x cubed minus x squared minus 13x minus 6. And I'm dividing it by this factor, which I've proven here. The factor is x plus 2. So I put that x plus 2 in there. And then I just do what I did in the polynomial division video. I say x goes into 2x cubed, specifically here 2x squared. And I multiply down, as discussed in the polynomial division video, and then I get 2x cubed plus 4x squared. I subtract, saying 2x cubed minus 2x cubed is 0, minus x squared minus 4x squared is minus 5x squared, and then I bring this value down, the minus 13x, and then I go again. X goes into minus 5x squared minus 5x times. And then I multiply down again, and I say minus 5x times 5 is minus 5x squared. And then minus 5x times 2 is minus 10x. So, subtract again, and then we go minus 5x squared minus 5x squared is 0. Minus 13x minus 10x, which is then plus 10x, is going to be minus 3x. And then one last time, bring down the minus 6. And we say x goes into minus 3x minus 3 times. And if I multiply down, I get that minus 3x. And if I multiply down, I get the minus 6, which should happen. I should then go and say minus 3x minus 3x is 0. But more importantly, minus 6 minus 6 is 0, which is my remainder of 0, which is part of the factor theorem. And as you spot, this gives me exactly the same quadratic trinomial that I found by means of inspection. So either way, I can then find that quadratic trinomial, which then just simply has to be factorized into this. So eventually, my final answer for this particular question is this over there. That factorizes into these 3 linear factors. So, tricky, I know, but there's very good news at the end of this lesson. And the very good news is pretty much all of this, the calculator will do for you. So that's the super, super, super good news when we get to the next lesson. Now, one last example to finish this. And this is example 2 on page 179. It says, if it's given that fx is equal to minus 2x cubed plus x squared minus 4x plus 2, firstly, prove that 2x minus 1 is a factor. So in order to prove that 2x minus 1 is a factor, we now first have to go and we have to sub this. And I'll just remind you again, we're going to do the 2x minus 1 equal to 0, which means x is equal to a half. So that's what I'm going to have to sub in to prove it's a factor. So I'll go the f of a half is then equal to, and I am going to use the calculator here again, minus 2 times a half cubed plus a half squared minus 4 times a half plus 2. And that ends up giving me 0. So that means yes, x minus 2 is now 2x minus 1 is a factor of that. Now what we're going to have to do is we're going to have to use this tip they gave you in order to factorize that fx completely. So we're going to say that means my fx is then equal to minus 2x cubed plus x squared minus 4x plus 2. So just writing that one down. And then I'm going to go and say, but I do know from this top one that 2x minus 1 is the one factor. So now what I'm going to say is I'm going to say this binomial times that trinomial is going to be equal to that cubic polynomial. And I start by saying the first term multiplied by the first term has got to be equal to that first term. Now I do have to say in this example, I honestly don't like that negative here, because the moment I put a negative here, I'm going to end up with the negatives into my trinomial, which is going to be super annoying. So what you might want to do, just to make this slightly easier, you might want to go and take the negative over here, take that out, and say this is now 2x cubed minus x squared plus 4x minus 2. That actually makes things a lot easier, but then that negative obviously needs to be transferred over there. So we start by saying 2x multiplied by x squared is going to be equal to, sorry about that, just getting distracted here. 2x multiplied by x squared is equal to 2x cubed, which is right. And then I also need to multiply this one by that one to get that minus 2. So negative 1 times plus 2 gives me that negative 2 over there. Now this is the only tricky part. So again, we're going to multiply these two to get the minus x squared. And then I need to multiply these two because there should be an x. We'll figure out what that coefficient is just now. So that 2x times that x gives me that x squared. Right. Now I know the end result has got to be this minus x squared. And then if you look at it, you go, oh, but there's already a minus x squared. So if there's already a minus x squared, what should this be? 0. Because minus x squared and 0x squared gives me minus x squared. So that one right there should then be plus 0, which then finally means I can factorize it as minus 2x minus 1 times x squared plus 2. And you could try this example on your own if you want, using long division, but I honestly think this inspection method is not too difficult. You'll notice I'm not going to continue because x squared plus 2 can't be factorized any further, because that's the sum of a square and then a normal number. So I can't factorize any further, so this is in fact completely factorized. And this is then using your factor theorem to factorize these cubic polynomials. So in the next video, we will look at the most important work in this chapter, which is solving third degree equations. Thank you guys.